All right, guys. We are gonna get started. Um, I hope you guys are doing well. Today is the fourth class. A couple of quick reminders: have you done the homework? Okay. And second thing is, if you're taking the April 2nd ACT, you should be registering for that one. Um, and if there is any questions for me, is there anything you guys might want to ask? Any questions? Any doubts? Um, if you're online, if you've done the homework, just do a thumbs up. And if you're here, just do the thumbs up as well. So 1, 2, 3. Homework. Okay, a lot of thumbs up. I'm still missing a couple of them because you guys have to do the homework. Without homework, it's just doesn't cut it. All right, let's get started. Page 4 of the math packet. Calculators, everybody. Degrees mode. Let's get started. Second class we did math. Third class we did science. Back to math today. We'll be on page 4 and 5 of the math packet. All right, so we're going to continue with our trig studies here. So we're going to be doing, we're going to start with trigonometric inverse, which is page 5. Yes?
What mode should our calculator be in?
Degrees.
Okay.
Third one on the mode. All right, let's get started. First question. All right, let's go. You can use page 5 and page 4. Page 5 is the inverse. We're going to start with inverse, okay? Easy question, around question number 40. Find x in degrees. Let's rock and roll. Should take you guys around 15 to 30 seconds time. All right, let's get started. So the advantage of knowing a trigonometric function is you can use the function to find an angle by knowing two sides. So a trigonometric function has three things: an angle and two sides, right? That's the greatness about trigonometry is it's so simple. So the first thing you have to do is to find what trigonometric function fits this given situation. Opposite, adjacent, tan x is equal to 17 divided by 21.8. X is equal to tan inverse, called trigonometric inverse. 17 divided by 21.8. Now please remember, I'm going to stress this many times. At least I'm going to repeat this 5 times today. When do you use an inverse, trigonometric inverse? Yes.
when you're dealing with angles.
When you're dealing with angles, absolutely. So if you want to find an angle, you'll eventually have to find an inverse. Or an inverse always gives an angle as an answer. Sounds good? Tell me the answer.
37.9.
So let's go with 38 degrees. Okay. Again, ACT doesn't care about decimals. You guys got it? Everybody in the calculator got it? And online students, I want to make sure that you guys respond, talk to me. It's very important that if there's anybody who is having any problems, you ask questions. So, when do you find it? When do you use an inverse? When do you have to find an angle? Third time. If you're looking for an angle, an inverse is a solution. Sounds good? The next question I'm going to ask you guys is a very important question. Was a 60th question in ACT. Many people have got it wrong because they don't have the basics. But if you think through this, I'm darn sure you guys will get this correct. Okay? Now, before we go to this one, I just want to have a quick reminder. You should have session 3 homework done today. Next week, homework 4 is due. And the following Sunday, that's 13th, is a Super Bowl. You guys good? No class that day. So I just want to have a clear idea of what your expectations are. And I believe the registration date for the April 2nd ACT is February 25th. So you don't want to push it to the last minute. All right, next question. This is a good one. This is put a big start to this. And let me complete the problem first and then you can do it. Okay? If you know the basics, you can do it in 30 seconds. If you don't know, you're going to struggle on this one. Okay, here you go. Again, give me time to complete this. Go. You cannot solve a problem if you don't know the question. You got to have a basic understanding of what is the question and what the end result is, step by step. And if you have an answer, online or face to face, I want to know your name. So just tell me your name once you're done. You're in advanced level, looking for a 36 in math. These are the problems that's going to start making a difference. Anybody? Nobody? Online students, anyone? Come on. You guys have to put in effort. Think. Once I do this, it's you'll like, oh my God, how did this happen? I'm expecting a lot from you guys. Period. You have to put in your efforts. Nobody from online? Here? Yeah, I'm pissed, guys. So, put your pencils down. Come on, listen up. Because just like you have expectations of me, I have expectations of you. Simple. All right. What did I just tell you guys about inverse? What does an inverse give?
Give a degree.
Gives the degrees and the angle, right? So last chance. What does an angle? What does an inverse do? It will help you find an angle. And how many angles are in a triangle?
Three.
And one of them is a 90 degrees, so that's not even considered. Am I right? So it's an angle A or angle B. So you have an inverse term here. The resultant of it has to be an angle. Yes or no? So, how is cosine defined as? So let's go with, cosine is defined as adjacent or hypotenuse. So which angle adjacent side is A? That's angle B. Am I right? So cosine B is equal to A divided by hypotenuse. So B is equal to cosine inverse of A divided by square root of A squared plus B squared. So this entire thing is angle B. Boom. Yes? And what is tangent B? Tangent B is opposite or adjacent. So cotangent B is A divided by B. So A divided by B squared. So A squared divided by B squared. Boom, done. If you know this, I expected you guys to know this. That's why I was talking about fundamentals. You with me on this? You don't know fundamentals, you will be stuck. Period. Questions? Any doubts? Anything you're not sure about? This is how you learn, okay? This is how you learn. Yes?
Can you explain it again, maybe?
Sure. How many angles are in a triangle? And
3.
3. In right angle triangle, one is 90 degrees. That's not even considered then. Okay. So look at the angle A and angle B. So when you have an inverse, the resultant will be an angle, either A or a B. So we have a cosine inverse of A divided by A square root of A squared plus B squared. So which angle has an adjacent side, which is side A, which is angle B? So this entire thing is angle B. And cotangent B is inverse of tangent B, which is B or A, so it becomes A or B squared. That's what I was trying to tell you guys many times, what an inverse stands for. That was the reason of this. So focus on the basics. You cannot escape basics. You with me on this? They'll catch you. If you want to get a 28, yeah, sure. But if you want to get a 36, every question matters, including this. Online students, do you have any questions? I hope it's fair that I have expectations of you, right? Otherwise, what's the point of doing this? Here's what I want you to do. First, I want you to write this looking at the whiteboard. Then, I would like you to redo this problem without looking at anything. Go. Got to learn, guys, got to learn. Ian, does this make sense now? Are you sure? So if I give you another problem, you're gonna get this?
We'll see.
Okay. You can't escape basics, you just can't. Somewhere eventually it'll catch up to you. Online students, any questions, anything you're not sure about? Yes.
In terms of the answer choices for like ACT, will it always be like the complete like a squared over b squared, or can it also be like the cotangent of b squared? Like, will they always?
For this problem, the answer was given this way.
Okay.
Yeah,
Is cot the same thing as tan?
inverse of tangent.
Okay.
So that's why I did tangent B, then cotangent is flip. Cool? Alright. Any questions on inverse? So what does an inverse give? An angle, right? Never forget that. Just can't. Because that's what it's used for. Alright. Let's keep it moving. I can almost guarantee somewhere in your practice you're going to come across this type of question. So. Next is directionality. Next topic, directionality and trig functions. Directionality and trig functions. In an xy plane, there's two possible directions. Counterclockwise, called the positive direction, called the terminal direction. Clockwise is called negative direction, called coterminal direction. Make sense? So the direction matters. That's good. So, I know I should explain it a little bit more, I know that, but I want to throw a problem at you guys and see if you can do it without me actually teaching this. Anyway, I'm going to do this again, okay? First question. Including directionality, what is the value of x? Go. If you don't know it, it's okay, we'll do it. What is the value of x, including direction?
What's the angle inside?
41. All right. So, well, we know this is all, the whole thing is 360 degrees, am I right? So, x is equal to 360 degrees minus 41 degrees. Am I right? 319 degrees, I believe, right? But what direction is it? Coterminal. And coterminal angle is? Negative. So the x is minus 319 degrees because of the directionality. Make sense? Cool? Second problem. What is the coterminal angle of 788 degrees? Try. Don't rush to any conclusion. Think through. Of course, I'm going to teach you guys this, but I want to see if we can try it. And again, if anybody has an answer, just unmute and tell me your name. Anyone? Yeah.
I would guess 107.
No, I'm not getting that.
428,
No.
68.
I didn't get that. But it was close. It's okay to be wrong. Then only learn. Gotta try though. Online students, anyone?
Negative 68 degrees.
Good try. No.
Negative 292.
That's what I got. Who's that? Is it Luke? Yeah, okay. All right.
Yeah.
Good. That's what I got. So put your pencils down. Let's do it. So, in an XY plane, what's the maximum degrees I can draw? 360. Am I right? Because it's a simple two-dimensional plane. So, I have 788 degrees. Of course, it's positive because I didn't. So, right, 360. How much am I left with? 428, right? So another round, 720. So I'm left with 68. So this is my plus 68 degrees, adding up to 788. So the coterminal angle is minus 292 degrees. Yes or no? Go ahead, right on. That's good? All right. Very closely associated to the directionality is what's called reference angle. Okay? 3 things to remember. A reference angle is always a positive angle. Okay? Always positive. And it's always between 0 and 90 degrees, like 42, 49, 3, whatever. And a reference to x-axis. Okay? So listen up. So let's take these 2 problems and find their reference angle. So it's always with respect to x-axis. So this is x-axis, okay? So right now, the reference angle for this particular angle is 41 degrees. So the RA is 41 degrees because it is from the x-axis, it's between 0 and 90, and it's always going to be positive. Sounds good? Same here, the reference angle is going to be, in this case, 68 degrees because it is from the x-axis towards it. So what will happen if you don't have the first quadrant? So the simple rule to remember is this diagram. This is how you can remember the reference angles. And we'll take an example. So you always take from the x-axis towards the angle. So if it's in second quadrant, you go this way, third quadrant, fourth quadrant, and first quadrant. But always has to be positive. That's good? Yes?
Can we do another one of these?
Oh, absolutely, absolutely.
I feel like I'm getting it, it's just,
I think the next one will seal the deal. Okay? All right. This is an important problem, so question number 3. What is the terminal angle and reference angle of negative 1344 degrees? I want everybody to get this now. If you have an answer, tell me your name, please. Chase? Josh?
Josh.
Luke.
Okay. Anybody else online?
Ashlyn.
Okay. All right, let's rock and roll, okay? So this is negative 1,344 degrees. So the first thing is to do in a real ACT test as well is to draw XY plane. So this is negative 360, direction is important. Another negative 360, negative 720. Help me here, negative
1080,
1080. How much have we left with?
264, I think.
264, so 180, okay, should be, how much you're left with in second quadrant?
6 degrees.
No, 264, 180, 84. So it's gonna be somewhere here. So this is what's gonna be left. Am I right? So what's gonna be the terminal angle of this? The terminal angle would be from here to x-axis from this one. So it'll be 90 plus. This is what,
6. 96.
so it'll be 96 degrees. So the terminal angle of negative 1,344 degrees is 96 degrees. And what's going to be the reference angle? Reference angle is this one right here, because it is from the second quadrant. Make sense? So the answer, so this was an ACT. I just included reference angle as an extra, but the question was, what is the terminal angle of negative 1,344 degrees? This is how the question was given. I just added the reference angle to it.
Manoj.
Yes.
So terminal angle can only be in one reference angle can only be in one quadrant.
Yes, because reference angle is between 0 and 90, so it will be in one quadrant. Does that make sense?
Yeah, I forgot about that.
So your reference angle cannot be, yeah, it cannot be more than 90. Yeah. But for the terminal angle or the coterminal, you always start from here or this point and go this way or this way. That's good. Okay, open page 6. Let's keep it moving. We're on page 6, radians and degrees. Okay. So converting degrees to radians and back. And the relationship is, just like 1 feet is 12 inches, there's a relationship here, 180 degrees is pi radians. Of course, you all know pi stands for 3.14 and stuff like that. Sounds good? So this is the conversion factor. And I actually want to teach a little bit fun math for you guys. Maybe you know it. If you don't, no big deal. Okay? This is fun. Okay? So this is the radius. So the circumference of the circle is 2 pi r, right? Everybody knows this equation. So listen to this carefully. Whether you have a small radius or a large radius, right? The maximum it can rotate is how many degrees? 360, am I right? So if pi is 180, what should be 2 pi? 360. So this is the constant in the circumference. That's how they got circumference, angle times the radius. Angle will never change. Radius will change. Small radius, small circumference, large radii, larger circumference. You with me on this? So this equation was derived from this conversion factor. Make sense? First question. Find 2.25 pi radians 2 degrees. This was in ACT, I believe was question number 41 or 42, I don't remember exactly, but it was 40-ish. 2.25 pi radians to degrees.
Ashlyn.
Mm-hmm.
Jack. Luke.
Okay, Luke, tell me your answer.
I got 4 or 5 degrees.
Yeah, that's correct. That's right. So 2.25 pi radians. So the very simple way to do this is what is pi radians? 180 degrees. So you're replacing this with 180. Make sense? Yeah, if you know it, you can do it in 10 seconds. If you don't, doesn't matter how much you can stare at it. Doesn't matter. Just move on. This is the hard reality of ACT or SAT. If you know it, done. If not, just waste time. You with me on this? So be real of what your expectations are. Question number 2. Convert 84 degrees to radians.
Ashlyn.
Mm-hmm.
Ria.
Luke.
All right. All right, 84 degrees radians. Now, you may have got the answer, but ACT may want this in a little bit different format. So listen up. So, just like a unit conversion, 84 degrees pi radians is 180 degrees. So this is your conversion factor, right? Because the degrees and the degrees will cancel. I want everybody to get your calculator. Because ACT, this is how they do it, okay? Come on, get your calculators. Do 84 divided by 180 and hit enter. I'm just want to make sure that you all follow with me here, okay? Then do math at the top left, math, number 1, enter. You get a fraction form, right? So this becomes 7 pi or 15 radians, and this is exactly how the ACT will give the answer. Or maybe once I've seen where they put pi as 3.14 and multiplied by, you know, and they got 1.47 radians. But this is what I can almost guarantee you'll be expected to. You guys got that? Now, there's another way to test your answer, by the way. Pi radians is 180, right? So if you put 180 here, 7 times 180 divided by 15, you'll get back to 84. Okay, you can double check that answer. But this is what they will be expecting, and only one time I've seen a decimal form of this. But this is what you should be expecting. Cool? I want to do one more. I'm not comfortable. So convert 725 degrees to radians.
Ashlyn.
Mm-hmm.
Jack.
Getting a 145 pi or 36 radians. Is that what you guys getting? What's the decimal value of that one, just in case?
4.027 repeating.
It's
No,
12.
no, that's not
with,
making
with,
sense.
with pi?
Yeah, with pi.
Oh, I don't know.
It's 12.653.
All right. I'm gonna give you guys 2 minutes time to review all the problems we have done today. Go back, let's go. Because this can only stay with you when you put in the effort to keep looking at the material. Otherwise, you're gonna forget this. Any questions? So far we have done almost all of trig. There's still more left, of course. Then we finished the degrees, radians, directionality, reference angle. As of fourth class, I'm pretty well caught up, like where I'm supposed to be. So I wanted to be at this point at the end of fourth Sunday, so I'm right there. Okay, so we want to complete as much as. To be honest, we want to cover more actually than usual this time, and I think so far so good. Of course, we did science last week. All the procedures and stuff, whatever strategies we have to do. Then we got to get to the practice, okay? And there's a lot to work on that as well. So, really want you guys to keep doing the homework. That's like a bare minimum, and start putting efforts, okay? I've been hearing so many things about ACT and SAT lately, but one thing for sure, if you don't have a good score, it'll reduce your scholarships. That will not change. So take it or leave it, but the fact is, if you don't have a good ACT score, it'll really come back and hurt you guys. Sounds good? We'll take a few minutes break. Lauren will be here to start reading today, okay? So, see you guys, stay here, bye-bye.
Thank you.
Uh-huh.
Thank you.